now we're going to see the pressure exerted by the gas molecules on the collisions. So remember that we had our wall, we had the molecule here, then goes here. We have a velocity component on x, velocity component in y. The y component does not change, just the b component, the b sub x component would change and would be opposite. So here our b1 would be equal to the absolute value of bx, and our b2 would be minus or negative or absolute value of bx. Now, so we saw that for the collisions to occur on a time interval dt, the distance was the velocity times the time. So all the molecules that are at a cylinder distance of the wall, the collision will occur. So the volume of the cylinder, if this is the base A, the volume was A times V sub 1 dt. Here we have a fixed number of molecules per volume, so N over V. If we want to find N, we will multiply N over V times V. So we have N is equal to N over V times V, V being A times the velocity times dt. And so half of the molecule will be towards the wall and half away, so we have that 1/2 of N over V times A times the velocity dt is the number of collisions that will occur on a dt time interval. Now the pressure, or well, first the momentum first and then the pressure. So what is the total change, or what is the change of the total momentum of the particles? So we're not talking about the momentum of one particle but of all particles. So here we have 1/2 of N divided by V times A V1 dt. If we multiply this times 2 times the mass times the velocity, that is why this? Because the change in momentum of one particle is the change, let's say for this, is going from, or is going, the change in momentum is this momentum here at the beginning was minus the absolute value of v sub x times m. Here the momentum is minus, is positive velocity in x times m. So p2 minus rho 2 minus rho 1 is this minus this, so we have 2 mass times the absolute value of the velocity. So this is the momentum of one particle. The momentum of all the particles that are colliding, that is of the collisions that will occur, is this multiplied times this. So this is the change in momentum. This is the change in momentum. Now the rate, the rate of change of the momentum, that is rho x divided by dt. First, let me operate this. Here we have 1/2 that dies with this, so it is only the number of molecules times the area times the velocity square. The absolute value of the velocity square is the same as the square of the velocity times the mass divided by the volume. Here you can also see that all this is volume, so we can cancel this volume and we will have just the momentum times the number of particles. Anyway, here, and so we want the rho in the t, and then we have the number of molecules times A times the velocity square times the mass divided by the volume. So this is the force. And now we have that pressure is equal to force divided by area. So the pressure would be the change in momentum in time, that is the force, divided by the area. So here we have this divided by area, so here divided by area, and we have just n times the velocity squared times the mass divided by the volume. So the pressure exerted by the molecules on the molecules of gas on the wall depend only on the mass, the velocity, and the number of molecules per volume.